we're going to talk about the inference about 2 means a dependent matched pairs. Okay, first of all, look at the notation. Mu sub d is the mean value of the difference d for the population of paired data. D is equal to the individual difference between the two values in a matched pair. D with a bar is the mean value of the difference d for the paired samples. So what we're talking about is the average of x minus y datas. S sub d is the standard deviation of the differences for the paired samples. N is the number of pairs of data. We also have some requirements. The sample must be obtained by simple random sampling or come from a matched pairs design experiment. The sample data are dependent. The differences are normally distributed with no outliers, or the number of matched pairs is large, greater than or equal to 30, and the sample values are independent. So our hypothesis test that we will run is the null is mu sub d equals 0, and then the alternative is mu sub d is not 0, it's greater than 0, or less than 0. So please notice what we're going to be doing is stats, test, and then t-test number 2. So if you want L1 to be bigger, you do a right tail. And if you want L2 to be bigger, you do a left tail. What we'll do is we will just draw a picture and look at the data. Okay, example. In a low-speed crash of 5 BMWs, the repair costs were computed for a factory-authorized repair center and an independent repair center. Is there sufficient evidence that alpha equal to 0.01 to support the claim that the independent center has lower repair costs? So alpha is 0.01. Okay, usually the authorized is L1, this is L2. This is a little bit tricky because L3 is what we need. That's going to be the difference. So you want the independent to be less than L1. Okay, so normally L3 is going to be defined to be L1 minus L2. So what we want to do is we're going to subtract the L2 over. So what we're looking for is 0 is going to be less than mu d, or mu d is greater than 0. So your null is mu d equals 0. Your alternative is mu d is greater than 0. Okay, now what we're going to do is we're going to do L1, L2, and L3. So we have to put this into edit. So we're going to do stat and edit. Okay, so before we do anything, we're going to put the data in. We're going to let the calculator find the difference by doing L1 minus L3. I'm sorry, L3 to be L1 minus L2. Okay, so if you count 1, 2, 3, 4, 5, there are 5 matched pairs. So what you're going to do, once you get your data in, you go over to L3, go to the top, so you're highlighted on L3, and type in second one, which is L1, minus L2, and it finds the difference for you. So now we're going to do stat, test, and it's a t-test, okay? So it's stat, test, and we're going to do the t-test, which is number 2, second test. And you're going to use L3. Okay, so you're going with data. Your mu is 0. Your list is L3, and you're going to choose that mu is greater than mu naught. So we want to be greater than 0. Go down to calculate, and your t value is 3.21. Your p value is 0.016. Again, using p and alpha, and we compare those. 0.016 to 0.01 is greater, so this is a do not reject. There is not sufficient evidence to conclude or to support. To support the claim, that mu d is greater than 0. So we can't say the independent center has lower cost. We can't support that claim. All right? Example, a researcher wants to compare the pulse rates of identical twins to see whether there's any difference. Okay, so this mainly, the difference is mu d is not equal to 0. Because look, we're looking at differences. So here you have mu d equals 0. Mu d is not equal to 0. Alpha is equal to 0.05. And again, I would do L1, L2, L3 is L1 minus L2. Remember, it's a t-test. T-test. I know we have two sets of data, but we're finding the difference. So we're just using L3. So your test value is 0.978. Your P is 0.36. How do we compare? How does 0.36 compare to 0.05? It's greater, so we do not reject. There is not sufficient evidence. To support the claim that there is a difference in pulse rates of the twins. Example, to test the belief that sons are taller than their fathers, student randomly selects 13 fathers who have adult male children. So what we want, we have L1 is the father, L2 is the son. We want sons taller. So we want L2 greater than L1. Now remember, we define L3 to be L1 minus L2. So if you move that over, 0 is bigger than L1 minus L2. So that tells you L3 has to be less than 0. Or in this case, mu d is less than 0. So you have mu difference equals 0. And mu d is less than 0. So it's not arbitrary. It's actually using some math to be able to come up with what we want. And I think it's easiest if you write the equation and always do L1 minus L2. Okay, alpha is equal to 0.10. T value is negative 0.393. P value is 0.351. So again, how does our P compare to our alpha? So that's 0.351 is greater than 0.10. So we are going to do not reject. There is not sufficient evidence to support the claim. That sons are taller than their fathers. Okay, we can also talk about a significant difference. So looking at confidence interval estimate for the population mean difference. Notice this is a stat test T interval number 8. And again, we're going to choose L3. So we want to know if there's a significant difference. So here's L1, L2, and L3 is equal to L1 minus L2. Your confidence level is equal to 0.95. So again, we're going to plug it in the calculator. And this time, make sure you choose T interval number 8. So I'm going to have to plug this date in. So we have stat. Go to edit. So I'm going ahead and I clear my L3, because it's a little bit backwards. Okay, so we'll put in 0.582, 0.481, 0.841, 0.267, 685, okay. Then we do the other one, 0.408, 407, 512, 402, 456, 0.533. Now remember, you can do L3, L1 minus L2, stat, test, and we want the interval number 8, T interval. And you can pick data. L3, your frequency is 1. Your confidence level, make sure you have that right, 0.95. And then we calculate. So please watch out for the confidence level. And we get negative 0.092 and then 0.28802. Now please notice you have a negative and positive, zeros included, so there is not a significant difference in response times. Remember, all we're trying to do here is to decide if there is or there is not a significant difference. Okay, listed below are the heights of candidates who won presidential elections and the heights of the candidates with the next highest number of popular votes. The data are in chronological order, so the corresponding heights from the two lists are matched. A well-known theory is that the winning candidates tend to be taller than the losing candidates. Find the 99% confidence interval of the mean difference in candidates. And then the question is there a significant difference? Okay, so again, with mean, notice we're using L1 and L2, the winner, the runner-up. And again, your L3 is L1 minus L2. So you get negative 1.622 to 0.3722. Notice your interval is negative positive. So there is not a significant difference.